So this is the question GATE 2012, question number 13, which states that a classical gas of molecules each of mass m is in thermal equilibrium at the absolute temperature T. The velocity components of the molecules along the Cartesian axis are Vx, Vy and Vz, which are given, and the mean value of Vx plus Vy whole square is to be found out. Based on these four options, we have to select one of the options which goes close to this mean value of Vx plus Vy whole square. So as you can see that this is the classical gas of molecules each having mass m and having at temperature T. So these, and it's particularly its velocities generally follow the kinetic theory of gases and the Maxwell-Boltzmann statistics. So based on that, we will try to figure out what will be the correct option. So to proceed with, we have noted down that what are given in this particular question. So it is given that a classical gas of molecules at temperature T and each having mass m. Now gas molecules have velocities in x, y as well as z direction. So therefore the x direction velocity is Vx, Vy and Vz. Remember, these are the velocities, so it will have directions. Classical gas molecules will follow the Maxwell-Boltzmann distribution. This is the concept which we have seen in kinetic theory of gases. So this is the concept which we need to use here. And based on that Maxwell-Boltzmann distribution of the number of molecules which is there in between V and V plus dV, that is nothing but d and v, that we can find out. Using that, we can find out the root mean square velocity, and this root mean square velocity is the total velocity square and then take its average. So when we do that, this is actually the mean square velocity. This is nothing but the mean square velocity because we have not taken the root, so it is the mean square velocity. When we take the root, it becomes the RMS velocity, the root mean square velocity. So when we have not taken the root, it is just the definition that it is a typical average definition, v square dnv divided by 0 to infinity dnv. Now dnv from Maxwell-Boltzmann distribution is actually dependent on some constant v square e to the power minus bv square dv. Therefore this, if we replace this dnv with all these expressions, we will get in terms of with respect to this integral with respect to dv. And since all possible velocities are considered here, so we have taken the limit from 0 to infinity. And we get the solution as 3 kbt by m. Now Vrms becomes root 3 kbt by m because this is the mean square velocity. We have taken the root of that. So it becomes root mean square velocity, root 3 kbt by m. But we will use this particular expression 3 kbt by m. Because as you can see from the question, that is we need to find out the average of Vx plus Vy whole square. So squaring is there. So that's why we will use that. Okay, now so if we write this Vx plus Vy whole square and average it, within the average we can write this Vx plus Vy whole square. We open this bracket, we get Vx square plus Vy square plus 2Vx dot Vy. Can be written as Vx square average plus Vy square average plus 2 into average of Vx into Vy. That can be written as Vx average and Vy average in multiplication. Now in a gas, you have in the x direction, suppose, see the gas molecule can move both ways, either positive x direction or negative x direction. In both ways it can move, so either in positive x direction or in negative x direction. So these are the two probable states. So these are the two probabilities. So molecules moving in x direction, molecules moving in plus x, we will take it as half number of molecules will be moving in the plus x direction, half number of molecules will be moving in the negative x direction, because it is too large number of particles are there in this Maxwell-Boltzmann distribution. Since large number of particles are there, so it will follow the exact statistical or the probabilistic phenomena. So half is the probability that half of the molecules will move in the positive x direction, half will move in the negative x direction. Similar case in y direction as well. So if we average now, this Vx, what will happen? So since equal number of molecules having x or positive velocities in the x direction and y direction and negative velocities in the x direction and y direction, the mean velocities will be 0, because these Vx and Vy all are the velocities. So this will be 0. This will chop out to be 0. In the real a real system, it might be possible that it is very close to 0, not exactly 0, but in general we will take the statistical sense that it will be 0. Now what we are left behind is that Vx square average plus Vy square average. Now since all the directions like x, y and z are equally probable for the actual velocity, so we can write this each direction velocity square have probability 1 by 3. Therefore Vx square average is equal to Vy square average is nothing but 1/3 V square average, which is the net velocity. Like the V square is nothing but Vx square plus Vy square plus Vz square. So it is Vx square plus Vy square plus Vz square. This is the definition of the net velocity. And since x, y and z are equally probable for each molecule, therefore it becomes 1/3 is the probability. Therefore Vx square itself becomes 1/3 V square average. And this V square average is nothing but the mean square velocity, which we have seen, the expression of that we have seen. Therefore this particular term which we need to find out becomes 1/3 V square average plus 1/3 V square average becomes 2/3 V square average, and this is nothing but VRMS square, and this becomes 3 kBt by m. So 2 by 3 into 3 kBt by m, 3 cancels out, we get 2 kBt by m as our answer. Now if we look at this particular question, so option D will be the correct option. So D will be the correct option. So as you can see, this will follow the Maxwell-Boltzmann distribution and through the RMS velocities, and based on the concept that each of the molecule have a probability, means system will have a probability to move, so half number of molecules can move in the positive x direction as well as negative x directions, similarly in the y directions, and Vx, Vy and Vz all are equally probable. Therefore 1/3 is the probability for that, for each and every directions. And based on these two probabilistic and statistical concept, we have come out to this particular expression, 2 kBt by m. Thank you.